Hi, everyone. Hey. So, I'm Matteo Collina at Matteo Collina on Twitter. I work for a company called Nearform. We have a nice booth outside. Come talk to us if you like things Node.js and if you want to talk about Node.js. We are there. I don't know, might be of interest. So, today we are talking about Node.js process that are on fire. What does it mean? Well, it comes out from a lot of our experience in running Node, Node at scale and Node in production. So all of this starts with a very, very, very bad moment. I don't know. You all probably been there. Everybody of you might have been called on a Sunday morning at 7 a.m. because something was down. I don't know. How many of you did? How many of you happened? Sundays morning? Yay! Fantastic. It's real 7 a.m. was. It's a really good time. Yeah. It's a good thing. Yeah, it's a good thing. So there's a big alarm in production. Things are down. Things are burning. The world is burning. Ah! What should we do now? Well, my autoscaling grew up to the maximum amount of things and is falling down on his knees. We are losing money. Your boss calls you and it's, whoa, bad moments. So typically we don't lose our cool and we fix this, typically ramping up, rebooting things. Hey, that mostly works most of the time. So we basically reboot our servers, increase the number of servers on our autoscaling groups on AWS or whatever you are using. Please use a cloud provider, whatever you want, whatever is good. You can configure autoscaling, so basically it grows up and down, whatever. So basically now things are cool again, everything is happy, your boss is happy, you're not losing money anymore, which is a very good thing. What all of you should do after this type of incident is doing a post-mortem analysis. What does it mean? Well, you should check what went wrong so that you're not called anymore at 7 a.m. or earlier, because it can always get worse, okay? So how do you do that? How do you prevent things from happening in the future? You need to look at things under the microscope most of the time to understand what happened. So, and more importantly, the second question is how to fix. Because, you know, knowing what happened is just the first start. How to fix the problem? How do we fix the problem? So first thing of all, we need to gather some diagnostics and evidence to understand what happened. This is a very, very clear, important part, because if we don't understand what happened, it's very hard. If we don't have any data about what happened, it's very hard to understand what was the problem. So we need some diagnostics data, and then we need to reproduce the problem. If we can't reproduce the problem, we can't fix it. This is one of the hardest tasks at all, which is very dependent on your code. So it's very you're basically responsible for this, okay? So reproduce the problem. Spend enough time to reproduce the problem until you can reproduce the problem. Typically, Mars might need a line to the moon to be able to do that, but whatever. And then after you reproduce the problem in a non-production live environment on the cloud again, I want to be able to reproduce the problem here. If I can't reproduce it on my development machine, I can't fix it most of the time. Because if I need to reproduce it to test if my thing fixed it, I need to wait for 30 minutes or 20 minutes deployment time. Well, I have my Docker containers that needs to build. I need to deploy them to whatever cloud I'm using. Whatever. It takes a long time. So I need to be able to run my synthetic test on my box. Even if it's just a tiny sample version of it, it might not be able to run the full thing, just a tiny little thing. And then I can get some more diagnostics data and evidence. And then try a fix for the problem. And if not fixed, go back to the previous step and try again. Because it's really important. This is a critical part in running a production application. Fix the production problems you have. Otherwise, those things piles up. And then it's a very bad thing that a couple might cross at the same time. And then it's very hard to understand what's happening. So fix them as soon as they happen. To go back to the state, to a nice roadmap for the problems, you have a performance issue on step 1 Okay, and the second thing that you need to do once you have a performance issue, you need to gather some diagnostics, which is typically coarse-grained. So basically, if you get any diagnostics from a live system, you are I don't know, thousands or hundreds of thousands or millions or billions of concurrent users. It's very hard to say what caused the problem. Okay, so it's coarse-grained, it's polluted. There's a lot of things there. In that step, you should probably use an APM, application performance monitoring. There are plenty on the market. I don't want to prefer anybody. There is a very nice thing called Elastic APM. That's there are friends, whatever. You can also use New Relic. You can also use Dynatrace. You can also use whatever. There are plenty. So you gather these diagnostics from a production system. Then after you have done that, you reproduce it on your staging environment, which is there for that specific reason. Use it. If you don't have a staging environment, set up one right now, which is a hard step. Okay, as I said, it's very hard. And after you have done that, you can gather some more clean data from your APM system. It's way cleaner now because you can only put the amount you are controlling the amount of traffic that you can send there. You actually controlling, you can reproduce the problem. So now you can control the amount of data that you get. And then you reproduce it on your dev machine so that you can hack on it and do things. And then you can get some more fine-grained things that are not you can't get in production. Why? Because they cost too much. They have too much overhead. I can get as much data as I want on my local box because it's not a production system, it's not live. If I run it on production, it might cause more problems. And then it's my favorite step. So I have a dog. She's a tiny poodle. And in order to fix the problems, I typically walk my dog. Okay? That's what I used to do. I also tried the other way of doing things, which is staring at a screen for a very long time. Also, that works. Probably not as nice as walking the dog. You can choose. And then you need to repeat these steps a lot in order to fix the problem. Maybe there is a better way, right, to get a performance. We want to get a performant application. Maybe there is a better way to fix a performance problem, a production problem. This might be a better way, maybe. So the first thing you need to do when doing this, when trying to reproduce the problem, is establish a measurable goal. What does this mean? We need to specify some metrics. Okay. What happened in this situation? I put in this input, I want this output. Okay, it's your test. Then you measure to see if my application meets that measurable goal. Then I find the bottleneck, which is what is causing the problem. I optimize, fix it, hey, and measure again. And maybe I go back to step one if it's not fixed. How do we establish a measurable goal? Well, you might choose whatever you want, really. It's about typically the 91 percentile of response time. This is a very good one. And you need to specify typically a certain amount of concurrency per server or something like it. Anyway, you should be able to specify this type of things in a synthetic way to be able to reproduce. And what happens? Well, one of the key problems is that in Node.js, latency and throughput are tightly connected. This is one of the key major difference of Node from other environments. So in Node.js is single-threaded. You probably all know this by now. This is not totally true, but we only run JavaScript on a single thread. In Node.js, we have multiple I/O actions that run in parallel, right? Which means, but when, if all those I/O actions are a database connection, if my database slows down for whatever reason, there is a missing index. This is a typical case. So my application slows down because there's a missing index on my database. So, and the I/O latency of my queries goes up. What happens in your application is that your application is able now to accept more requests. So it's handling a higher concurrency. But higher concurrency means higher memory usage. Why? Because I have 1,000 concurrent users or 100,000, those users, those requests, have some memory attached to them, right? This means that high memory usage means higher GC activity. right? However, GC, the garbage collector, because we don't free our memory, costs some very precious CPU time to run. So all things are connected. And if I waste my time running a lot my garbage collector, I can't spend my time to reply to our users. So it's all come out. You can see a missing index problem can show up as a 1.5 gig node process. Why those two are connected? Because of this. So this is my nice acronym. You like my nice acronym? This is fantastic. MFOMF, fantastic, I love it. That was my take, I don't know. So you establish a measurable goal, you measure, you find the not bottleneck, you optimize, you measure again, you go back to the find the bottleneck if you didn't fix the problem, and repeat, and then you finish. It's fantastic. The acronym is fantastic, okay? I love the acronym. So how do we measure? This is important. I wrote this thing called AutoCannon. It's a tiny JavaScript module that you can use. It's a HTTP 1.1 load tester, but it's written in JavaScript. So you can code your scenarios in JavaScript. Now, there are others that are probably better and you have used, but we are JavaScript developers, so you probably don't want to write this in Lua. You probably don't want to write this in Java. You probably don't want to do whatever. There are others that has been done in JavaScript. This is as fast as WRK or AB, which are probably the fastest two tools written in C. 10 minutes left, fantastic. I started 5 minutes late though, so can I get 5 more minutes? Fantastic. So here's how you use AutoCannon. You start your server, then you specify the concurrency, the number of concurrent socket, a duration, and some HTTP pipelining factor if you want that. And you specify your HTTP URL, and it has a nice progress bar because we love those in Node, and we get the data. Okay. So how do we find the bottleneck? Right? We have measured. We have established our measurable goal. We have measured. How do we find the bottleneck? We need some diagnostics, okay? I am on my machine, I need some detailed data. We have wrote this is called Node Clinic, and it's a new tool that enables you to self-detect performance issues. So how does it do? Well, Node Clinic has several commands in it, okay? Several subtools that you can use. The first one that we're going to demo is Doctor. So Doctor is this nice guy. Hey, it's a nice guy that help you to self-diagnose your problem. Now, I am on battery, on a MacBook, with a projector, with Wi-Fi, whatever. Everything can be bad, so the demo god should be with me. If you have ever done any live coding or anything like that, you know what it is. So, so what you're going to do is clinic, doctor. Wait a second. I have it already written, so hey, here we go. So we are doing clinic doctor. Clinic doctor has this nice flag on port, which enables you to run a command at the moment that your app is available. I started listening on the port with 100 concurrent connection and for 5 seconds. And you specify your node executable and the file that you want to run. This uses some experimental features, so try this only on Node 8.10 plus. And after you've run this, then we analyze your data and then we plot. So this that automatically detects, for example, that you have an event loop issue. So it automatically tells you that your problem is your application is blocking the event loop. What does this mean? This means that you have a synchronous JavaScript call that is blocking the main thread of your application. While that is blocking, no more requests can be served. So we want to resolve that problem. So the most important thing is that we show also some recommendation. So we tell you that you might want to mitigate implementing a 503 event loop protection. So basically, if my event loop is busy, start returning a 503 immediately, because otherwise I might not be able to reply anymore. But we also recommend to diagnose the problem, use clinic flame to discover what is actually blocking the event loop. We also provide a read more section, which is very long and detailed, with a lot of links, so that you can read through and document yourself. We also have some other issues, so we can also help you detect, we automatically detect if you have an I/O issue or a garbage collection issue, so that you can, and we recommend tools and approaches for those as well. So what is the next step? The next step is Clinic Flame. Clinic Flame is based on this thing called 0x, and I'm going to demo this right now. So again, the demo god should be with me, and we just swap the name of the tool, Clinic Flame, and keep the same. So we provide a very similar user experience, and let's see how this goes. Demo gods. Takes a while to generate these things because it's very heavy analysis and generation parts. Ideally, should have been done by now. So demo god should be with me. Hey, yeah. So here it is. You see that this contracts is not really good on this screen, but you see this is a very hot thing at the top. Okay. So it comes out in red. The darker the red is, the hottest that function is. And this shows you, you might not be able to read it. Can you read what the text there on the first stuff? It's called sleep. Okay, there is a sleep. That's what it was low. So let me show you the function. And here it was, what was the function? That was the function. So sleep. Okay, that was the problem. Hey! By the way, there are several other things that are slow that you might not know in your application that are doing something like that. If you iterate over an array of 10,000 elements, that you get the same amount of filling. And you might not know it's there because it's on some dependency on downloaded from npm. So, what else? So this was Clinic Flame, and this is the flame graph, whatever. Yep. So a couple of things that are important. All of what I've demoed to you, it's working on Linux, Windows, and Mac. So all these tools also run on Windows, which some of you might be very important. Also the flame graph part, we recently released it and updated it, so it runs on Windows. This is fantastic, okay? Before that, it was very hard to generate this type of data on Windows. And it also supports kernel tracing. So if you want to run it on production to debug some issues on a C++ add-on that you have been using, you can use kernel tracing to dig into that, because right now it's built on top of the V8 prof, some V8 mechanism, so we only see JavaScript. And yeah, it's very fast. So a most important thing to note is most code does not need to go to ludicrous speed. How many of you have seen Spaceballs? Fantastic. If you haven't seen Spaceball, go see Spaceball. It's fantastic, part of geek culture. And you know, your code do not optimize when you do not have a problem. Okay, fantastic. So on top of this, I wrote this new framework called Fastify. Why? Let me show you an example. Okay, so let's show you this code, demo Express. So this is a typical Express app. Okay, how many of you have written this app? So let's generate a flame graph for this. Okay, and let's generate a flame graph and let's see how that look like, what the profile of that look like. Takes a while. This, by the way, this is a fantastic machine for traveling, but not so much for performance. So this is my flame graph, okay? Now you can see that the hottest part of this code is this header function and this send function. These are the hottest thing in this piece of code. Okay, so we are spending most of the time of this critical example in doing .send and in doing the headers, right? Now, let me show you the same thing for Node Core. Okay? Does the same thing with Node Core. You can tell it straight away from this thing. One is 7,000, the other 14,000. This is what Node Core look like. Where it does Node core spends most time on this thing. You can't read it because of the projector. But this is socket underscore write generic. So let me see if you can read it. If I over it, do you read this? Yeah. Fantastic. Okay. You see socket write generic. It's a function in Node core. It's the function that you call to write something to a socket. So it means that this is the hostess function. Probably it's good. Okay. At least is what Node tells us. But if we go back to this is what Express was doing. Okay, you see there is a lot of things that Express is doing for making things happen. So let me show you Fastify. So demo Fastify. This is Fastify. We use a nice JSON schema thing to be able to render our JSON faster. We wrote this library called fast JSON stringify to do that. And let me show you. No, got it wrong. And I need to run this for Fastify. This is Fastify. And it's a tiny little framework similar to Express or Happy or what you've used, but with a lower impact on throughput. It has this thing, it's a bug that appeared in the latest version of Node, I don't know what it is, but you see this is Fastify. So it's very similar to what we generated for core. This is the core one, and this is the Fastify one. You see there is other stuff happening, but way lower, okay? Other things that if you are into performance and you want to improve your application, this is Fastify. Yeah, this is the diagram, sorry. I had to put this in. This is Express, this is Fastify, and that's Node core. I wrote a library called Pino. It's a tiny open source logger, which is typically faster than the alternatives. We are going to release to another version 5 soon, which is even faster. You are probably using one of the other popular logger, but this provides similar output and comparable with way less overhead. Okay, it's time for closing up. I'm almost running out. First of all, I want to say one thing. Tomorrow I'm doing a workshop. So if you want to do a workshop on performance, tomorrow at 11, I think, we are doing a performance workshop showing how to debug a performance problem. So we will give you a slow REST API to fix. And we will walk you through the steps that are needed to fix it. Well, we will let you do it. I won't do anything. So it's pretty interesting. And if you are into these topics, please come. I want to thank Nearform. Again, it's a company that sponsors most of my work. And to be able to work on this tool, Clinic came out of our own ideas, and it has been a very nice response. So I hope you like it as well. I also want to thank the team of people that wrote all this tool. My contribution to this has been this presentation. So these are the people that needs to be thanked for. Not really me. Andreas, Joy, Connor, our CPO, Matthias Boos, Macintosh, you probably know this guy, Alan, Camille, and David McClemens that wrote 0x. So this presentation is available in a couple of places, so you might want to take this and check it out. Goes back to me. I'm probably almost running out of time. So this is me. I am part of the Node.js Technical Steering Committee, which is the body that governs Node.js. So if you have any questions about Node or want to have get some answers about Node, please reach out. Also, I work for Nearform. So hey, we are in business. We do Node.js support. We can develop projects for you. We can do whatever. So if you need any help with Node.js on your project delivery, we do from design to this thing. By the way, all these designs were done by the design of Clinic and so on, were all done by us. We run design sprints and so on. So it's really even that as a very good thing. Thank you, guys.